afternoon, everyone. Hope you can hear me okay. I think this is it for the second session here. We've got a few colleagues here joining us today. My name is Sean Fraser with Nozomi Networks, and I'm going to go through a use case here or a mock scenario with a company, Acer Tech, where they're going through a digitalization journey, and we're going to talk to some of the steps and challenges they're going to encounter along the way, and what the potential solution could be, and how they can get visibility in their OT environment and get a handle on the kinds of assets they have, the vulnerabilities, and really get the true picture to everything that's going on in their OT environment. So for the agenda here, we have who is Acer Tech. We got some of the market challenges, differentiating factors between IT and OT, and the path forward. Let's set the stage here. Acer Tech, they're a company founded in 1985, sorry. They've been around for nearly 40 years, and they are involved in the manufacture of steel parts. As they've been around for so long, it's a brownfield environment, and they have a wide mix of different manufacturers from one plant to the next, and therefore makes it very challenging to standardize on any single solution. They're involved in the automotive, aerospace, and construction space, which tells us they may have some compliance requirements, certainly in the aerospace, and they are now embarking on their journey towards Industry 4.0. They have an ultimate goal to improve efficiency, productivity, and flexibility. If we look at some of the challenges that they're going to encounter, of IT systems and OT systems will create new opportunities for cyber criminals to exploit potential vulnerabilities, i.e. widening the attack surface. And the interconnected IT systems and smart devices used in 4.0 also represent very attractive and appealing targets for malicious attacks. As we take a look at some of the market challenges, we know that cyber attacks have been ever increasing in the manufacturing sector. And, we know through speaking with many executives that the frequency and nature of these attacks is only increasing, as majority of manufacturing customers have some kind of digital transformation roadmap in place that they're working towards. And as a general outcome, they're expecting that they're going to gain efficiencies by going on this OT and IoT journey, by being able to squeeze more value out of less. So working with the existing systems that they have, but to get better efficiencies, get them optimized to get more out of them. We also know that manufacturers in particular are dealing with the perfect cybersecurity storm. We can see that attacks on manufacturing space is up almost 4,000%, where we had less than 10 in 2013. We're now up to over 400, and that's only of those that are actually reported. So many more of those attacks go unreported and are undocumented. So we know this number is increasing and increasing significantly. If we take a look at some of the top markets to inflict maximum pain, manufacturing is the top target for big game hunters. Why? The impact is significant. We saw in 2021 that over 228 incidents that resulted in a complete shutdown of the business, and system outages are far more costly to manufacturers than in other sectors. The downstream effects can also take months, if not years, to fully recover from. And as manufacturers digitalize, there's a significant need to be able to mitigate and reduce downtime while still ensuring business continuity. On one hand, as the assets become connected, so too does the attack surface increase exponentially. But on the other hand, the whole process in and of itself may cause disruptions in the manufacturing process as these new assets become connected. And so maintaining visibility through the entire journey will be of paramount importance for both IT and OT. But why is OT different? Well, if we take a look at this example here, digitalization really creates some distinct but operational resilience concerns for both IT and OT. So on the IT side, the need to secure a vast array of diverse systems, but they can't protect what they can't see. And so they need a platform that gives visibility across all systems that works well with their existing tools and platforms. However, all the visibility in the world won't help if these IT or help IT, sorry, um, if they have no tools to be able to truly identify and resolve the vulnerabilities and the threats that are in that environment. And OT needs something that's not going to get in the way of their existing processes. They need something that'll focus on uptime by providing insights into potential points of failure. And where their primary concern in OT is about production and maintenance teams at plants are concerned with securing systems not typically considered, such as the CCTVs and the HVAC systems. And any system necessary to ensure production and quality targets are met needs to be visible and secured. And so it really comes down to the visibility for both IT and OT. So as factories digitalize, it'll be mission critical for them to have access to everything on the network with a real-time look, with a true understanding as to the threats that actually surround them. Here's a fun one. Hey, honey, how was work today? As we can see here in this OT environment, um, we have networks, we have technology that's interacting with one another, and we have an example here of what happens when something goes sideways. So what was the failure here? We don't know. But when bad things happen in OT, there are real world implications here, as you can see. I like to show this slide because this is a very good level setting slide. When we look about some of the differences between IT and OT, we take the IT model, which is CIA, confidentiality, integrity, and availability. And it's really taking in that order, in that level of importance. Whereas when we step over to the OT side, we take that pyramid, we flip it upside down, and we add an S on top. Where is the S in safety? And having a clear understanding of these nuanced differences will also give us a clear understanding as to how we must tackle these environments and tackle them differently. Oftentimes, we'll find that we are brought into these discussions by the IT team, or that the IT team is asking the OT team for some similar metrics towards visibility as they would see in their IT environments. However, the differences are nuanced and quite vast. There's no way to get OT visibility, monitoring, and analytics onto an IT solution. It's just too complicated, and there's just way too many attributes and variables to support. You might say OT is harder in many different ways. For example, um, in IT, when things go bad, things go dark. In OT, things go boom. And I like that. As that previous example alluded, when things go sideways, things make sparks, things make noise, and that's a problem. The controllers and the networks use proprietary protocols that are not widely known or even documented. So using an IPT strategy just isn't going to work. You have a heavy use of air-gapped environments, and the byproduct of that, you have very insecure OT network designs because they haven't had to worry about security. And even more so than that, the devices themselves just aren't built with security in mind from the ground up. From a life cycle perspective, IT systems are constantly rebooted for patching and maintenance, yet an OT system is expected to run 10, 20, or 30 years, and it needs to stay online continuously. Shutting down an OT furnace safely could take a week and more, and the maintenance windows are extremely rare and far between. So these are all some of the very high-level examples to what is different in the OT environment, and as such, we have to take a different approach into securing it. Another consideration would be how you're going to address regulatory mandates. And so as we heard from the panel before, we were talking about data protections and standards to be followed and so on and so forth. And more we're going to hear about that as the years go on. And in fact, while I've called out standards like 62443 or NIST or NERC-CIP as a variety of different frameworks, we also know that the SEC is now mandating that any publicly traded on the US stock exchange must report on what they do to protect their OT and their IoT environment, right? And so as these reporting requirements become mandatory, or table stakes, if you will, for someone to be on a publicly traded environment, you need to have tooling in place to be able to meet these mandates. So the path forward requires a unified approach that combines responsiveness and efficiency and business resiliency across your IT, your IoT, and your OT environments. So the path forward, you need some kind of solution that's going to provide you secure visibility for any device anywhere. And you need a solution that where when you deploy it in the environment, it's really like turning the lights on in a dark room. A solution that's going to be able to help you identify all these devices that were previously unknown, but you want it to do that in a very passive way. You don't want to be running scans in your network. You don't want to have to block traffic. You want to be as non-intrusive and non-invasive as possible while still being able to derive the full picture to all these funny devices that are out here. Whether it's your standard work laptop or smartphone or printer, or to these more obscure OT devices, like your conveyor belts, your PLCs, your remote IOs, your camera systems, your HVAC systems, and so on, and everything there in between. We want to be able to get full visibility of all these devices and understanding them intimately. You want a solution that's going to provide value across three main buckets for visibility, detection, and response. And so on the visibility side, I'm saying being able to passively build you out a long list of all your assets in your OT environment, being able to provide you with the make, the model, the firmware, and the serial number. But once you've collected that information, to be able to further correlate that against any known vulnerabilities that might be associated with those devices. So now you're able to build out passively a long list of all your assets, all the details about them, and also the known vulnerabilities so you can start building out a security posture. With that, you also want to be able to continuously maintain and monitor that environment. So continuous threat protection and monitoring. So being able to identify things like malware, your Stuxnet, your WannaCries, your Dragonflies, and so on. Being able to identify erroneous behavior, where new devices are being plugged in, or maybe devices are misbehaving, malformed packets, misconfigured devices. These are all things you want to be able to pick up with the particular tool you're deploying in your environment. You want to be able to combine signature-based anomaly detection along with behavioral-based anomaly detection to be able to detect zero-day threats, for example. Then lastly, on the response side, though, what do you do? What do you do in the event of an alert? What do you do in the event of some kind of attack or some kind of threat being identified? So you need some kind of tool that's going to give you the necessary capabilities to A, identify, and then B, mitigate and respond and do that deep dive. And so giving you the ability to see, okay, how was my network working before and how is it working today? What changed? Giving you playbooks to be able to walk you through step by step what you're going to do. And really just to give you that actionable intelligence that you need to be able to move forward and get past the event. Simple as that. You need something that's going to fit nicely into your existing framework. So as many clients will have a much wider and broader system, you want to be able to tie it all together through a series of integrations.